Hello everyone, today let's solve the problem number 62, unique paths. So what the question states here, a robo is placed at the top left of an M into N grid. You can clearly see here. So just give me a second here. So yeah, you can clearly see here, right? A robo is placed at the top left of an M into N grid and can move only right or down. Either robo can move right or either robo can move down, right? So that's what they have given in the question. So we need to compute how many unique paths exist. So how many unique paths exist for the robo to reach the bottom right corner. So here whatever they have given finish here, this is the bottom right corner, right? So how many unique paths are there to reach for the robo from here, from the start to finish or the bottom right corner? That's what they have asked in the question. That's what we need to find out basically, right? So again I'll read out, just try to listen to this. A robo is placed at the top left of an M into N grid and can move only right or down. So we need to compute how many unique paths exist for the robo to reach the bottom right corner. This one, right? Simple to understand. Let's come to the first example here. In this case, so here M equals 3 they have given, right? M equals 3, row equals 3, and this one N column is nothing but they have given 7, right? So there are 7 columns here. 1, 2, this one, 2, 3, 4, 5, 6, 7. 7 columns and 3 rows, right? So they have given here 7 columns and 3 rows, right? So that's what they have given here. So the number of ways for the robo we need to calculate basically. It is 28 they have given, right? There are 28 such ways they have given. So how we got 28? Let's discuss the same thing while we discuss the approach basically. So let's go with the second one here. M equals 3, N equals 2 they have given, means row 3, column 2 they have given here. Output is 3. From the top left corner, there are total of 3 ways to reach the bottom right corner. They have said right, down, 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 right, down, right, down. That's what they have mentioned here, right? You can just go through this one. Let's discuss the same thing during the approach. So I hope question is completely clear. What we need to do is completely clear as well. Means what we need to find out basically, right? So let's discuss the approach followed by the edge cases one by one, and then finally write the code and discuss the complexities for the code that we have written. Initially, as usual, let's discuss the approach first. So the first thing that we need to note down here is we are going with a 2D DP, right? So we are going with the 2D dynamic programming, basically bottom up approach, right? Or bottom up tabulation, you can just call it. So 2D DP will be going with, right? So I've considered the first example, the same example that they've given in the question mainly. So this will be easier to understand. M equals 3, N equals 7. The output that we need to get is 28 here, right? So there are 28 unique ways they have said. So how? Let's calculate the same thing, right? Let's see the step-by-step execution here. So here in this case, first what we will do, we will initialize first row and first column. So we will initialize the first row and first column because robo can either move right or down. That they have clearly mentioned in the question. Robo can either move right or down, right? So we will this one fill all the right and down this one cells with 1 initially, right? So this one has been question mark, right? So this we have to fill it, right? So this is fine. This is the first step basically. Let's move on with the second step here. We will fill the rest of the grid by making use of this formula. For all dp of ij, we will compute dp of ij equals dp of I minus 1j dp of I plus dp of I minus 1j. Means from the above it is dp of I minus 1j, from left it is dp of ij minus 1, right? So this has to be dp of ij minus 1 basically, right? Sorry, yeah, this is fine. So let's fill the first row first. This one I'm speaking of. This is the first row, right? This is 0, 0. This is starting from. Let's fill the first row first. So here in this case, we are going with dp of I minus 1 from I minus 1 j from above, and from the left it is dp of I j minus 1, right? So in this case, it will be initially it will be 2, right? So here it will be 2, right? So when we apply the formula here, it will be 3, 4, 5, 6, 7 we get. You can just check the same accordingly with the formula. So we are going with this dp of I minus 1j, dp of ij minus 1. So let's move on with the row 2. So now we have, we know how we got 1, 1, 1, 1, this one, first step, initialization part. Now we know how we got 1, 2, 3, 4, 5, 6, 7. Same, how we got the second row, let's do the same thing with the this one, what do we call, row 2 as well, right? So here it will be 2 plus 1 3, this one will be 3 plus 3 6 here in this case. So same goes with 10, 15, 21 and 28 as well. At the end, the bottom right, this one corner, we have the last value. The last value in the cell means the bottom right corner. The value in the bottom right corner, the last cell is 28. So this one we will return this one as output basically 28, the last one. So we are going with a bottom up approach, right? So we always return whenever we go with the bottom right, bottom up approach, we will return the last cell, the value present in the last cell as output. We know this one. So we have solved n number of DP problems by now, right? So we should be knowing this by now. Sorry. Yeah. So now we will return 28 as the output. Basically, the bottom right cell, DP of 26. This is nothing but DP of 26, right? So here you can clearly see cell coordinates. DP of 26 is 28. This one is our final answer. This one is our final answer. So we have 28 unique paths that exist from 0, 0 to 2, 6. This one 0, 0 to 2, 6. So I said we'll be discussing this one in the approach, right? So now we know how we got 28 basically. We have 28 ways, 28 unique ways we have. 28 unique paths exist, or 28 unique ways we have to reach for the robo to reach from this one 0, 0 to 2, 6 basically, right? So the output that we got is 28, which is equivalent to the output that they have given for the first example in the question, right? So this is 28. This is fine, right? So the approach works absolutely correct in this case. The approach works absolutely correct in this case, right? So let's quickly, as we are familiar with the approach, let's quickly discuss this one edge cases one by one. So let's come to the edge cases here. Just give me a second here. Let's come to the edge cases here. The first edge case is for the single cell grid, right? Let's go with the single cell grid. Just give me a second here. This is not working. What happened? Yeah, this is fine. So here, single cell grid means m equals 1, n equals 1, row and column. We are pointing this one to the 1 and 1, first row, first column, right? So output will be quite obviously 1, only one way. So here, let's go with the second edge case here, single row grid, right? So here we have m equals 1, n equals 5, right? N equals 5 means this one row we have 1, but the columns we have is 5. So it can only move right, only one path exists here, so output will be quite obviously 1, right? For the first one, it is already at the destination because only one possible path. So here in this case, row 1, column 1, so output will be 1. In this case also it is 1. For the second one, single row grid, for this also it is 1 because we have 5 columns and 1 row, right? It can only move right, only one path, that is that itself we have to return 1 as output, right? Let's move on with the third edge case here, single column grid. So when I say single column grid here, m equals 5, n equals 1 we have. So row 5 we have, and column we have only 1. So here also the output will be 1. Why? Because it can only move down. So previously we were able to move only right, one path, right? So here this time we can only move down one path. So it can only move down. So only one path exists in this case. We have to return 1. So let's move on with the fourth edge case here, smallest square grid. When I say smallest square grid, so row has been given 2, column has been given 2 as well. So output will be 2. So output will be 2. Why the output will be 2, not 1 here? So you 2 unique paths exist right here. So we can move right and down, or this one down and then right. Both are possible. These two ways, right? So these are the 2 unique paths. So output that we need to return here is 2 in this case, right? So these are the 4 edge cases that we need to keep in mind. The first edge case is for the single cell grid, the second edge case is for the single row grid, the third edge case is for the single column grid, and the fourth edge case is for the smallest square grid. So these are the 4 edge cases that we need to keep in mind, right? So I hope all the edge cases as well as the approach is completely clear, right? So now we are completely familiar with the approach as well as the edge cases. As we are familiar with both, we are good to write the code. Let's start writing the code. So let's start writing the code. The first step here is we will create the 2D DP array of size m into n. Right? So we have already discussed this one. let me give here dp equals new. I'll just go with n 2d dp, right? So this is of the size n, basically I'll just give n here. This is fine. So we have to fill the first column with the ones and the first row with ones as well. So let's write two for loops here. So int I equals 0. This was the first step, right, that we discussed on the approach. So this will be I less than m. Let's increment the I. So within this for loop, what we need to do, just give me a second here. Somewhere I did wrong. We are filling the first column with ones, right? So I'll just give here dp of I 0, this one 1. This is fine. So next, now we have successfully filled the first column with ones. Now we have to fill the first row with ones as well. So let me copy the same thing and make the necessary changes here. Just give me a second here. So yeah, this one will be, instead of I, I'll make this one j equals 0. This one j, column n, right? Column is n, so let's increment the j here. This is fine. So instead of this one dp of I0, this one will be dp of 0j, which is equal to 1, basically. So we have successfully filled both first column and first row with ones. So the next step after this is we have to start from the second row, right? So now we have already filled the first column and the first row with the ones. Now we have to start from the second row and from the second column. And for that, we'll be making use of the for loop. Within that for loop, we have to sum of the top and left cell. So we went with the formula, right? dp of this one, if you remember. If you remember the formula, I forgot the formula basically. So that's what we use the formula to find out this one, right? To calculate the second row as well as the third row entirely, right? So this one, first we'll start from the second row and we'll start from the second column. For that one, we'll be making use of the for loop. I'll just go with for int I equals 1, I less than m. So let's increment I. This is fine. So within this, one more for loop, this one int j equals 1, j less than n. So let's increment the, this is fine. So within the for loop, we have to go with the sum of top and left cell. So this will be dp of I j. So we are going with the 2d dp, right? So just give me a second, what happened here? Yeah, this is fine. dp of, what's the formula we went with basically? dp of I minus 1 j. So this is the formula. So I forgot this one actually. Yeah, dp of I minus 1 j plus dp of I and j minus 1. So this is how we calculated the second row as well as the third row during the approach, if you remember, right? So we got in the second row, we got 1, 2, 3, 4, 5, 6, 7. In the third row, we got 1, 3 something. Last at the bottom right corner, we got 28, right? If you remember. So this is how we calculated dp of ij equals dp of I minus 1 j plus dp of I into j minus 1. That's what we did. So the final step is we have to return the bottom right cell value, the last cell value, the bottom, this one, right cell value as the output. So that's what we need to implement the same in the form of output, or we need to articulate the same thing in the form of output here. So I'll just go with m minus 1 and n minus 1 here, the last cell, bottom right cell. So return dp of m minus 1 into n minus 1. So let me format the code once and let me hit the 1 button. So here we have the error. Incompatible types we have cannot be converted to int. dp equals new int of which one? The line number 3. What's wrong here? So yeah, we are going with a 2d dp, right? So this one, let me give one more square bracket here. Let me run this one again. So I hope this works now. Let's see. Runtime error we have. Array index out of bounds exception. Index 2 out of bounds for length 2. So this one is less than m. This is fine. We are incrementing. dp of I0 equals 1. This is fine, right? Oh yeah, what mistake I have done here is in the line number n, 3, basically this has to be mn, right? Rows and columns. So I have given n. This is fine. So now this has to work. Let me hit the run button again. So yeah, you can clearly see. So instead of m, I had given n. That's the reason we were getting error basically. So now the sample test cases are getting passed. Let me hit the submit button quickly. So I hope this works for all the test cases. Let's see. So now you can clearly see here, all the test cases are getting passed. Means the code works absolutely correct in this case. So let's quickly discuss the complexities for the code that we have written, right? So the approach that we went with here is 2D dynamic programming, or we can just call this one 2D bottom-up tabulation, right? So mainly we went with a DP, right? So overall time complexity would be here. In this case, it would be big of m into n. So what would be the space complexity here? The overall space complexity would be big of m into n. This is fine. So the time complexity and the space complexity for the code that we have written is big of m into n, right? I hope this is clear. So I hope the complexities are completely clear. I hope whatever the code that we have written is completely clear as well, right? For now, this is it. Thanks for watching, guys.